Alright, so in this STEM problem solving walkthrough, we are going to be talking about Diophantine equations. This is also doubles as an Algebra 1 video. So we're going to be talking about Diophantine equations, and we are going to be solving them. So Diophantine equations is when we have multiple solutions. We have pairs of integers. Usually in problems, you're asked to find pairs, all pairs of integers, or all pairs of positive integers. You might be asked to find all pairs of negative integers. Or you maybe there's lots of possibilities when it comes to Diophantine equations. Today we're going to start off pretty basic. Xy plus 2x plus 3y equals 5. Now we want to find all pairs of integers such that the equation is equal to 5. Such that xy plus 2x plus 3y is equal to 5. Now I want you to come up with a strategy from what we've learned in Algebra 1. Right? We've learned we can apply everything we've learned to this right here. And we're going to use some useful factorization. That's just one hint. So hopefully you've come up with a way to simplify or to make the equation easier to handle. I see xy plus 2x. I'm going to factor this to see if it makes it any easier. So I can have y plus 2. This is xy plus 2x plus 3y equals 5. So we can factor everything but our term over here, which is the plus 3y. Now over here, what if we had something like this? Well, if we had the y plus 2 term and we factored out a 3, if we factor out a 3, we would have 3y. We already have a 3y, but then we've had a plus 6. So what I'm going to do is we're going to use some algebraic manipulations in this problem. We're going to manipulate the equation by adding 6 to both sides of the equation. So I'm going to have y plus 2 plus 3 times y plus 2 equals 5 plus 6, which is 11. And we can just erase our expansion over here since we already have our factorization. Now this can be factored into, we're using some useful factorizations here, a product of binomials. X plus 3 multiplied by y plus 2 is equal to 11. Now, we're trying to find every single pair of integers such that this is equal to 11. Now, how are we going to find all pairs of integers such that this is equal to 11? Alright. Notice how we need to find a product of two numbers that equals to 11. 11 is prime, so there's only 1 in 11. But we want all integer solutions. So I'm just going to start off. We are going to have 1 times 11, negative 1 times negative 11. That's a possible case. We have 11 times 1, and we have negative 11 times negative 1. Now over here, we're finding all pairs of integers. So we can set x plus 3. We can set x plus 3 over to the 1 equals to this 1 right here. And then we can have y plus 2 equals 11. And then we can have x plus 3 equals the negative 1. And y plus 2 equals the negative 11. X plus 3 equals the 11 over here. Y plus 2 equals 1. And then x plus 3 equals negative 11. y plus 2 equals the -1. Now these are all of our cases. We've successfully broken down to a product of binomials, and now we can find all pairs of integers. Now x plus 3 equals 1. Now all we need to do is take 3 over to the other side, subtract it off, we get -2. So if we have x first and then y, I'm going to erase this. X first, then y, we're going to have -2, and then we're going to move on to this. Y plus 2 equals 11. Subtract off the 2, we get 9. So you have that as one of our solutions, and we can actually just erase all of our work because we already have all of our cases. We already have all of our cases. Now, that's these two. Right, we're done with these two. On to the next pair. X plus 3 is equal to -1. So x plus 3 is equal to -1. Simple linear equation, take the x, -1 minus 3, that's a -4. -4, and then we have y plus 2 equals -11. Well, we take the 2 on the other side. 11 plus 2 is 13. Slap on the negative. Yep, over here. Those are two solutions to our thing. And now we have a couple more cases. X plus 3 equals 11. Well, subtract off of 3, 11, 10, 9, 8. That means x is equal to 8. Y plus 2 equals 1. Take the 2 of that, subtract off the 2. We get 1 minus 2, which is equal to -1. Now we have our last set of cases. We have x plus 3 is equal to -11. We take our plus 3, we bring it over to the other side, subtract off the 3, we have -11 minus 3. Now 11 plus 3 is 14. Slap on the negative, we get a -14. So over here we have a -14. And now we have y plus 2 equals -1. Well, same thing. Y is equal to -1 minus 2. We take the 2, we subtract off on both sides. We get -1 minus 1 minus 2. 1 plus 2 is 3. Slap on the negative, we get -3. And now we can see that we have some integer solutions to our problem. Yeah, 8, -1, -14, -3. These are all pairs of integers such that xy plus 2x plus 3y is equal to 5. And that's how important manipulating equations can be when it comes to algebra problems. You might need to square both sides, subtract a number from both sides, or do whatever you can to make the equation easier to handle. Hopefully this video is helpful, and yeah, that's Diophantine equations.